Okay, so we are going to continue with this problem of throwing a football. I'm assuming all of you watched the previous video, so you have all this information written down. And where we finished was trying to determine how long the ball is in the air. So we took y, which is its height, set the height to 0, solve the quadratic out, and if you solve it all out, you should get t equals 2.18 seconds. So the ball is in the air for 2.18 seconds. Well, the next question you could actually ask is, if it's in the air for 2.18 seconds, how far does it go? But how far it goes is actually the horizontal distance traveled. So I can take my equation for x, plug in the time that I just found when it hits the ground, and then that will tell me how far it travels in the x direction. So I get x equals 50 cosine 40 degrees times time, which is 2.18 seconds. So like I said, have your calculators handy and do this out really quickly. Times 50 minus cosine 40. And we get 83.5 feet, because we're doing this in feet. So there we go. I throw the ball at a 40-degree angle from an initial height of 6 feet with an initial velocity of 50 feet per second. The ball stays in the air for 2.18 seconds, and it travels 83.5 feet horizontally. The last thing we could probably ask ourselves, maybe if we get rid of this information, if this is a parabola, maybe I want to find out how high it goes and when it reaches that maximum height. But it reaches its maximum height in terms of the y direction, which means I just need to find the maximum of the y. But the maximum of the y is just the vertex. So I can just find the vertex of this. You all remember the equation for the vertex. H is negative b over 2a. That's negative 50 sine 40 degrees. All over 2 times negative 16. The two negatives cancel. And then again, do the math on your calculator really quick. We won't be having round answers for all of these problems. 50 sine 40 degrees divided by 32 equals 1.00. So right at 1 second. And then what's the actual maximum height it attains? Well, it reaches its maximum height in 1 second. Its maximum height, we can just plug in here. And we get y equals negative 16 times 1 squared, which is just negative 16, plus 50 sine 40, which I'll get from my calculator. Again, the t is just 1, so it's irrelevant, plus 6. So we get 22 feet. Well, now, at this point, let's see. With these parametric equations, if you remember, from regular projectile motion, your projectile has to be going straight up and straight down. You can pretty much tell when it reaches its maximum height, when it hits the ground, and when it's at a given height, going straight up and straight down. Now, with these parametric equations, well, given this information, we figured out that the ball was in the air for 2.18 seconds, that while it was in the air, it traveled a horizontal distance of I erased it, but I think it's about 83 feet. And that while it was in the air, it achieved a maximum height of 22 feet in about 1 second. So there's a lot more information we can get out of our problem when we use these parametric equations. You don't have to have these basic equations memorized. They're in your book. You just need to be able to use them to solve problems. I think this is the third video on parametric equations, so this should be more than enough information to help you guys with your homework and to get ready for the test. But if there are any other questions, just email me, stop by my office, let me know, and I'll do even more of this.